Hello students, I'm Moseti Gilbert. I'm going to take you through program design, and we are going to deal with design strategies, and we are going to deal with 4 design strategies. First of all, we are going to deal with the monolithic design strategy, then the top-down design strategy. The third one is the bottom-up design strategy, and the fourth one is the modular design strategy. Let's start with the monolithic design strategy. What is a monolithic design strategy? This is a strategy whereby a program is written in a single function. The codes in a program are interdependent of one another. So, for example, we have a long program of 1,000,000 codes. So this program will be written in a single function, and all the codes in the function will be interdependent on one another. So this design strategy is very disadvantageous in that if you have to write a program of 1,000 lines, then you have to begin from the bottom and write all the lines from one line to the 1,000 one. Another disadvantage is that this program design strategy is not readable. If you want to debug a problem in this program, you have to go through all the codes for you to find the problem. The other issue is that it is not easy to upgrade this program. Another disadvantage is that you cannot reuse this program. And now let's talk of advantage. The only advantage it has is that it is suitable for only small programs. If you want to write a very small program, this is the design that is suitable for the small programs. Now, let's move on to the top-down design strategy. This is a strategy whereby you identify the topmost module, and you subdivide the module into submodules. Then you subdivide the submodules into smaller submodules. You do that until you reach whereby a submodule cannot be subdivided any longer. Now, in this design, it is very advantageous in that the main module is first developed, and then the submodules are developed later. Now, in this design, you can break the submodules, and then different programmers are able to work on the submodules simultaneously. Another advantage is that a customer or a programmer can see the progress of the development of this program. For example, you have started the top module, the submodule, so a programmer can come and or a customer can come and see where is your progress. Another advantage is very easy to debug this program that you develop using this design. Another advantage is that it's very easy to design this program. Now, the disadvantage part of it is that for you to break the main program into some modules, it takes a lot of analysis. Now, that is a very big disadvantage because a lot of time will be wasted on analysis of these sub-programs. And for you to develop the lower modules, that's the second disadvantage. you need to have the knowledge of the upper module. Now let's move now to the bottom-up design. This design is almost similar to the top-down design, but this one it is the reverse of the top-down design. Here you start with the lower levels, the small sub-programs. You develop them and then you debug them. Then you move to the higher level. You develop the smaller sub-programs, you debug them, you move until you reach the main program. Now it's almost, the advantages and disadvantages are similar to those of the top-down design. That is, you can develop the code using different sub-programmers can develop the program. The code is very easy to maintain and to upgrade. The code is readable. It's very easy to debug the code. Now let's move to our last strategy, and this is the modular design strategy. This is a strategy where you take a program and divide it into sub-programs. These sub-programs will be independent of one another. Now, this sub-program can be developed and tested separately, and then they are linked together to form a single program. In this programming, let's take an example of a mobile phone. Here is a mobile phone, and this mobile phone has a screen. This is the screen of a mobile phone, and this mobile phone has a battery. This is a battery which you can unmount this battery. Now, what happens if this battery is spoiled? You just go to the shop and buy another battery and replace it. What if the screen is broken? If this screen is broken, you go to the shop, you replace this screen, and the mobile continues to function. Now, with modular programming, it's the same case as this mobile phone, in that if you want to upgrade that code, you just have to go to the function that deals with that code. Let's take an example of a payroll system. If you have a payroll system and you have a function in that payroll system that calculates the payee of an employee, what if the percentage of tax is increased from 16% up to 20%? What will you have to do? You will have to modify the percentage. In order to modify that percentage, you have to go to the program. Now, in modular programming, you just have to go to that function that deals with the payee of the employee. You look for that function, you increase the percentage from 16% to 20%, and you are done. Unlike monolithic programming, whereby you have to go from the first line of code to the last line of code, trying to search where is that 16%. Now, with this modular programming, you just go to the function that deals with that payee calculation. That is the advantage of that modular programming, in that it is very easy for you to upgrade a code you have written using modular programming. Another advantage is very easy to debug. If you find an error, because this program is really into program into functions. Now you just have to go to the functions and identify a problem since these functions run independently. That's another advantage. Another advantage is that it's readable. This is just divided into subprograms, so it's very readable, unlike the monolithic programming whereby you have a line of codes. It's very readable. Another advantage is that this programming is very easy to use. Different programmers can run the codes, can develop this program simultaneously. For example, you have a bigger program, it is subdivided into modules, and you give different programmers to work on these modules. So these modules can be developed differently by different programmers. You don't need all the programmers to be there to run them. You just give them a module to go and develop, the other one a module to go and develop, and then they test it independently, and then they bring it together, and it makes a single program. That is a very big advantage of modular programming. Now we are through with the modular program design. Next lesson, we are going to talk about the control flow strategy. Thank you very much.